Hello, am I audible to you?
Yes, ma'am, you are audible. Good evening, ma'am.
Releasing a mock for your intern. I think two of the revision sessions are already done. So today I will do one more revision session. So since the mock is just released, I will to, yeah, need to see the result. Otherwise, I think by tomorrow they will definitely release. But after that, we are planning on conduct session. So today I will discuss half of the mock, and then you can attempt the other half, and we will discuss those questions again on Friday, right? And today, after that, I can take whatever doubts you have, if you have any from previous papers or anything. Okay, let me share my screen. Please, everyone, attempt this mock paper before the exam.
Ma'am, shall we get any bonus mark from this mock as well?
No, no, no.
Okay.
Just a second. Yeah, you will see the screen.
Yes,
Screen is visible, right?
yes, ma'am.
Yes, ma'am. Just now it got visible.
Okay. So see the first question. This is exactly the way in which your intern paper is going to be. Just 1 minute. Okay. So this is saying that the following pseudocode is executed using shopping bills data set. At the end of execution, A captures the highest price of an item purchased from Big Bazaar. Okay. So first of all, shopping bills data set, you will have the template given like other exams also. So what is present is items of particular person has purchased, per unit cost is there, total cost is there, the
Excuse me,
customer
ma'am.
name is there.
Hello.
Yeah.
Ma'am, this mock is graded.
No, no, mocks are not graded.
Yes,
They're
ma'am,
just for your practice.
this is graded. It is given. Deadline is 8 of this month. 8th of this month.
Is it written as graded?
Yes, ma'am.
Mock is not supposed to be.
Mock for quiz 1 and quiz 2 was not graded, but this is graded.
It is given as graded, is it? Because I think it is not supposed to be graded. Okay, let me check once if there are given grade status.
Ma'am, there was a bonus mark
Is it
like
given in the grading document that there is some bonus from this mock or something?
yes, ma'am. Bonus of maximum 3. I guess I'm not sure about it, but I guess it was 3 marks.
Okay, no issue. Then before I confirm that, I will not discuss it. So if required, we can discuss the mock on Friday session. So today, let's do another random paper instead. Why I wanted to do this today is because later on people will have revision sessions of other subjects also. Don't know how many will be joining.
Ma'am, can't we discuss this mock today? I mean,
Not discussing because if it is graded, then you should submit it first, right?
okay, ma'am.
I think if the deadline is 8th, so that is Friday. So 9th class we can discuss this.
Okay, ma'am.
Okay. So in the previous two sessions, what have you done regarding the centum division? Any papers were discussed? Anyone can update what you have done in the previous two sessions?
Well, I have attended one session and the PYQ for previous term was discussed in that session.
Okay, previous term. Okay, we will take another different paper. So the 2024 May term paper we are going to discuss. If that is already done, please let me know once. We'll just share the paper once now.
Ma'am, are you discussing the mock paper?
No, mock I'm not discussing today. Let's give you some time to solve it. If there is a deadline, then after the deadline we'll discuss.
Okay,
I
ma'am.
think it's 8. Okay, then you solve.
And ma'am, is this mock is one of the PYQ?
Mock is not PYQ. It is just to give you an idea of how the interim paper is going to do. It is not PYQ.
Okay, ma'am.
Okay, this is visible to you.
Yes, ma'am. It's visible.
So we'll just discuss this paper today. This is May 2024 term, set 2 paper. So first question is saying the given pseudocode is executed using sports dataset. What will be the value of count representing at the end of execution? Okay. So first see, count is set to 0. Now while table 1 has more rows, we will read the rows one by one and move it to table 2. Now first, inner while loop is saying that as long as table 1 has more rows, we will again choose another card while. So at a time we're choosing 2 cards, that means some kind of comparison is going to be there. Right, so card X and card Y we have. Now count variable is updated by count plus do something XY. So do something is the procedure call. So from here control shifts to the definition of procedure. So this takes both the cards X and Y. Now in the procedure what it is doing, it takes these two cards and it checks their genders, right? If X is if gender of X card is equal to gender of Y card and if they are also from the same town city, then we return 1, otherwise we return 0. Now, whatever you return will go back here and get summed up. So either you sum 1 or sum 0. So that means we are comparing every two pairs of cards. And if in both the cards we see the gender and the town city are same, then we are counting those cards in this count variable. Right? So what does count represent at the end of execution? Check the options. Which option do you think?
Option C seems to be correct.
Number of pairs of students with the same gender and same town city. Okay, anyone thinks any other option? This is correct, right? So this option C is our answer. So this is just number of people having same gender and same town city. Okay, next question C. Consider the following pseudocode at the end of execution. The following pseudocode, if flag has value true, then choose the possible values of L from the given choices. Okay. So we have to check that flag variable, if at the end of execution of this pseudocode, if flag has value true, then we have to choose that what can be the possible values of X. Right. That is, what can be the possible values of the list L. So first we see flag is set to false. Then position is set to 0. Position is a variable. For each element in L. So for every element in list L. But this question is not very well formed. It should have mentioned that L is a list. This is some procedure working on L. But anyways. So for each element in L, if position %2 is equal to 0, So position %2 equal to 0 means
If
position
it
is something even.
That means even.
Right.
even.
So position is some even value and element is equal to x. That means x is present at some even position in the list. Right. Then only flag will be set to true. So position here means nothing but the index. Right. So if x is present at some even index in a list L, then flag will be set to true and position will be incremented by 1 after every iteration. Why? Because we are checking index 1 after another element. So first starting from index 0, then plus 1, index 1, then index 2, like this. So out of these 4 options, can you see any option where x is at an even index, like index 0 or index 2?
Option A and C.
Flag will be set to true. So option A, we can see this is index 2. Here x is present. So this condition will be correct. So A is one of the possible options. B, this is index 1. X is not present anywhere else, right? So this is false. This one will be correct or not?
Yes,
This
ma'am.
is correct.
Why option 1 is correct? It is x is present in third position.
It is not an even position, right?
Yes, ma'am.
Option B, X is at position 1, index 1. So 1% 2 is not equal to 0. So the if statement will break. So A and
No,
C
ma'am.
are correct.
No, ma'am. Why option A is correct? It is given if position divided by 2 is equal to 2. Here the position of
Is
x.
equal to 0. So what
Yes,
is the
ma'am.
position of X in option A? 2, right?
Ma'am, 3. Oh, yes. 0, 1,
Index
2.
starts from 0, right? This is 0
Yes,
based
ma'am.
indexing. 0, 1.
Yes. Yes, ma'am.
So A and C are the answers. Same logic for option D, position 1. This will not work. This is clear, I think, for everyone, right?
Yes, ma'am.
Now, question 3, this is saying, consider the following procedure. Find something that takes L1 and L2. Two lists are there. If length of list 1 is not equal to length of list 2, then you directly return false. And if they're same length lists, then I will move further to this while loop. So if length of L1 is, as long as length of L1 is greater than 0, that L1 is not empty, then the first if statement is, if last of L1 is not equal to last of L2, then also return false. That is last elements of both lists. They are not equal. Then you return false. If they're equal, then you don't enter this if block at all. So here L1 is now init of L1, that is last element removed, same for L2. Okay. So first of all, what can we see here? That I will only continue with this part of the procedure if initially I see that L1 and L2 are equal length lists, right? Because see, inside the while loop at every iteration, one element is removed from each list. So overall the lists will always stay of the same length, right? Now, what is the other criteria for returning false? That if I see that corresponding last elements are not matching in the lists, L1 and L2. So technically we are matching every two corresponding element, right? Position, let's say each list has 5 elements. So we are starting with index 4 of both lists. That is the 5th element. So if those two match, then it's okay. If they don't match, then you return false. If they match, then next iteration you remove the 5th elements. Now you compare the 4th elements from corresponding lists. So that means when will I return true? If all elements in both lists are same, right?
Yes, ma'am. Yes.
Yes, ma'am.
So you just have to check the options and find out that which option is correct here. See, first option L1 and L2. First, our criteria is that they have to have the same length. These are same length. This is fine. But when I come and set the while loop, last of L1, last of L2. This is 5, this is 8.
Option C.
Option C would be
So
correct.
let's see how the other options are eliminated also. So 5 and 8 are not equal, directly false you return. This is not correct. Option B, what is wrong? Again, same number of elements, that is okay. So this is 5, 3. So this will return false. Option C, same number of elements. Every corresponding element is equal, 5, 5, 2, 2, 8, 8. So this will give a true value, because this will run until list 1 becomes empty. When list 1 is empty, list 2 is also empty because we are correspondingly removing each element from both the lists, right? So L1, L2, this option C will give true value. Option D will definitely give false because they're not same length. So here only it will return false. So only C is correct. This is clear for everyone?
Yes, ma'am.
Can this code work to check even length palindromes? Or it's odd length palindromes, any length palindromes? Can this pseudocode do that? Just yes or no?
Yes,
Can this
yes,
pseudocode check palindromes?
yes, ma'am.
Palindromes,
If
see,
the while within while loop, if last of L1 is not equal to last of L2, then it is
see, for
false.
palindrome checking, it has to be different, right? Because here what we are checking is corresponding elements are same. But palindrome itself has a criteria that the word should read same forwards and backwards. So that and this, these are two different things. I asked this question because lots of people made this type of mistake in other palindrome related questions where we check in this way. But there is a subtle difference between the two. Here, definitely the logic is a lot similar that you're checking corresponding elements from both lists and seeing if these two words match exactly. But it is not our goal to match the two words. Our goal is to check if both are palindromes. If you want to check for palindromes, right, then just checking the corresponding letters is not the goal. First, you check that the word reads same from forwards and reads same from backwards. So here, option C is correct. This one. So consider procedure given below where A list is a non-empty list of real numbers. Non-empty list of real numbers, right?
Ma'am, for palindromes, we have to remove first and last both element.
Correct.
Yes,
First
ma'am.
and last, both you have to remove.
Yes.
And we never check like this that two words are palindromes. No, we check whether a single word is a palindrome or not, right? It is not a comparison between two words. So this one we had was a comparison between two words to check if they're exactly same. So like words can be exploded to form list of characters, as you know. So that way we can do this. So here cumulative is a procedure which takes a list, which is a non-empty list of real numbers. So every element in a list is a real number. And the length has to be greater than 0. So sum is first set to 0. Cumulist is a new list, empty list. Now your for loop starts. So for each element in A list, so we'll pick every real number from A list, add it to the sum variable, and in the new list we add that number, but from the beginning of the list, and then return this cumulative list. Okay, so at the end of execution, which of the following options would be correct? So what can we say about these lists? So first option is saying, like if this was A list, okay. If this was A list, then sum will be what? 2, 7, 9, 4, 8. This is 30, right? So that should be sum at the end, and cumulist should contain all these elements only, but in which order? Reverse order. So I'm sorry, same order, not reverse. So we will start from here, right? First element. Now this will be added from the beginning of cumulist. So if it is first element that we are doing, then this list is empty. So it looks like this. Then 7, 2, 9, 7, 2, like this, it will end up having this exact list in the reverse order, right? So first option is saying the first element of both the lists, cumulist and A list, always will be same. Is it correct?
Ma'am, can you repeat this cum list,
Yeah.
like how
So
it
for
is being
this
generated?
iteration, what happens? First iteration, I'm picking this element, right, from A list. Now I have to add this element to sum. So sum, which was initially 0, is now 0 plus 2. So sum is 2. in this new cumulist, this sum, okay, sum is being added, not the elements.
Yes, ma'am. Actually, like 2, then 7 plus 2, just like that.
Yeah. Let's build this once. So in this new list, the sum is being added. So first you get 2. Now this is the only instance, right, where the first element of this cumulative list and the A list, they are both same. Now second iteration, when you go, sum will become 2 plus next element, which is 7. So this is now 9. In the new list, 9 is entered from the beginning, right? So it will be 9, 2.
Yes, ma'am.
After this, again, you will get plus 7, 16. So 16, 9, 2, like this. So first element of both the list, cumulist and A list, will always be the same. No. Only one iteration, they will have the same first element, which is then added to the cumulative list, right? So this is of numbers in decreasing order. Is this correct? This
Yes,
is right.
ma'am. It is
Because
correct.
every time we are doing the sum, we are adding the number from the front of the list. So of course the number will keep on growing because sum is increasing, but we are not entering from the last of the list. So it is decreasing order, strictly decreasing. So B is correct. C, say cumulative list is a list of numbers in increasing order. This is definitely wrong. And D's number of elements in both lists will be different. This is wrong. They will have the exact same number of elements because as long as there are elements in A list, the sum is getting added to cumulative list. Right. So as many elements in A list, that many elements in C list. So D is also wrong. Only B correct. Any doubt in this one?
No, ma'am.
Usually in this type of question, if we give the numbers and all, right, you might also get options that are the list, that what will cumulative list look like at the end of execution. So 4 lists will be given. Or maybe this can also be a part question. Okay. So the following pseudocode is executed using words dataset. Now we are using words dataset. Let unique L return the list of unique elements of L. What will count represent at the end of execution of pseudocode? What is unique L? It is the list of unique elements of L. Okay. So what will W count represent at the end of execution of the pseudocode? Ignore the upper and lower case. So case sensitive, it is not. Punctuation symbols and comparing other words. Okay. So first we have W list, unique list, and W count. So these two are empty list. This is empty dictionary. So while unique L is a direct procedure that we are going to use here, which we know that it takes some list of elements and it just returns the unique elements in that list. Right. Our job is to find what will this dictionary represent at the end. So while table 1 has more rows, now you go through each card in this words dataset. So each card contains what? A particular word, its part of speech, its letter count, and the unique serial number. Right. So first you append that word to W list. So now W list contains that first word, what you picked. If X word ends with a full stop, if that word is at the end of a sentence, then only the rest of all of this will happen. Right. That means if you are at the end of a sentence. So let's say this is my sentence. I am a student. Okay, so this is the first card, second card, third card, fourth card. So once I pick the first card, this does not end with a full stop. So W list contains I, right? But from number 6 onwards, this line 6 onwards, nothing will happen because X word doesn't end with a full stop. So we are going to come to this line here. Move X to second table 2 and again go for the next iteration. Then similar way you put all of these in W list. I am. Now, as soon as this student, this comes, right, this ends with a full stop. So now the if statement is correct. We are at the end of a sentence. Inside unique list, this empty list, We are calling the procedure unique and we are passing this W list. Okay. What will it do? It will just create a list of unique elements from this, whatever is present in W list. Now, since in our sentence, all the words are unique, so it will be returned as it is. If some word was, let's say, if I wrote student twice here, okay. If I wrote student twice, then student will be removed and only one occurrence will be shown in this unique list. Now, for each word in unique list, we will check if that word is a key of W count dictionary. If it is already a key, then this is key will return true and we will increase the frequency that this word has appeared one more time. If it is not a key, that is, this is the first occurrence of this word in our data set, then we will set the value to 1. That means W count is a dictionary that does what? It keeps a track of how many times each unique word has occurred throughout the data set. Right? It is just a frequency dictionary. For every unique word, it maintains how many times that word has occurred. So which option is correct here? What is W count representing? Look at
Ma'am,
this.
option A, I guess.
Look at this also. After this if block closes, right? This is the closing of the else block. This is the inner if. This is the inner for loop. So once this for loop closes, that means we have established that we are at the end of a sentence, right? So from this sentence, nothing more I need to add to W list. So I will again reinitialize W list to a new list. Okay,
Yes,
empty
ma'am.
list. And then I will again go through the cards and put the words one by one till I reach the last word of the next sentence and then again check the same thing. So first option is saying that it is a dictionary with words as keys mapped to the number of sentences in which the word is present. So if a word is present twice in a sentence, how many times is it counted? Only once? Because we
Yes,
are
ma'am.
checking that how many times this word has occurred in the sentences, right? We're not checking the word frequency, how many times the word occurs, in how many sentences this word has occurred. So first option seems to be right. Let's see the other ones why they're wrong. Dictionary with words as keys mapped to the frequency count of the word in the dataset. This would be true when we didn't do this unique list thing. So if I kept all the words as it is in a sentence, then I can say that, okay, for student, the frequency is increased by 2, right? If I had student twice in a sentence. But this is not checking word frequency. It is checking in how many distinct sentences a word has occurred. So option B is wrong. C is saying dictionary with words as keys mapped to the max frequency of a word in a sentence. Again, wrong. And D is saying dictionary with words as keys mapped to the number of sentences in which word is present more than one time. This is also not correct. This more than one time, this is not correct. We are not just counting those sentences where a particular word has occurred more than once, right? Even if it has occurred once in a sentence, we count it as one occurrence.
It
So
should be
only
at least
option.
one time, right? I mean, number of sentences where
Yes,
that word.
as long as the word has appeared once, that's it. We will
Yes, ma'am.
count that. Okay,
Uh,
frequency for frequency, we will not remove the unique thing. We'll keep it as it is. If a word occurs twice, thrice in a sentence, we count all those occurrences. That's frequency.
okay, ma'am. Ma'am, I just have a doubt here. Can you scroll up the to the pseudocode? So here, unique list is returning the unique words in a
Words.
sentence, right?
Yes. Yes.
And like in which order? Like whichever order
Or as it is
it
given. Yeah.
follows. So
Whichever order.
suppose, let's say, suppose student has occurred 2 times. So
Hmm.
which one, which student it
It
will
doesn't
remove?
matter. It can pick any. It can pick any. Okay.
Uh,
It will
okay, okay,
actually, if you go algorithm wise, I mean, if I have the algorithm for this unique procedure, it will actually count the first one because once you have the first one, that's the one with which you compare the other one, right?
oh,
So as
okay,
soon as you see that it is the same, you will reject the next one.
okay, okay. Suppose in this sentence, I am a student. Let's say student has occurred one more time in the beginning at the 0th index. So
Hmm.
then it will return
As zeroth index
student.
student will be considered. Yeah.
Okay,
Student I am a.
okay, 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 ma'am. That is what my doubt. Okay, thank you.
Okay, these questions are very important for random. Like this type of entities you'll definitely get from lists. So what will be the value of S at the end of execution of the following pseudocode? So L1, L2, both lists are given to us 1, 2, 3, 6, 5, 4. So S is what? Do something L1, L2 minus do something L2, L1. So same procedure being called twice with the order of the arguments reversed. And then we are just finding the difference, right? So if length of X is not equal to length of Y, then return 0. So length of X is not equal to length of Y. So I will just take our example. Length of L1 is 3, L2 is 3. This if statement is wrong. The same length. So next step is length of X is 1 and length of Y is 1. That is also wrong. Both have 3 elements. So nothing will happen. What will I return? First of X into last of Y. So first of X into last of Y. This is the first call of this procedure. Okay. So the procedure is calling itself again. So what is this called? Procedure calling itself. What do we call it? Recursion. Right. This is an example of recursive procedure. So first of X, last of Y. That is first of L1 is 1. I am evaluating this right. First of L1 is 1. Last of L2 is 4. So 1 into 4 plus again call do something with rest of X init of Y. Okay. So let's do rest of X. Rest of X is that is first element is removed. So 2, 3 init of Y last is removed. So 6, 5. Again, the same procedure is called, right? So now this call, this is the second call. Second call again check length is same, length is not equal to 1. So again return statement will be first of X into last of Y. This time first of X is 2, last of Y is 5. So 2 into 5 is 10. Plus again call do something with rest of X which is now 3. Init of Y which is now 6. Now in this third call of the procedure, length is same. But now length is 1 also for both the lists. Only one element present. So directly you will return first of X into first of Y. So this part returns 3 into 6 which is 18. This 18 goes back to the previous call. This here. What did I have here?
10.
It was 10.
Wait. 18 doesn't go there. 18 goes to this call, third call. Now 10 plus 80. 28 total from this third call. This goes back to the second call. 28 plus 4, 32. This goes back to the first call, this return statement. So what is returned at the end? 32, just from this part. Now we'll similarly evaluate this part. What does this give? So again, do something L2, L1. So now this is my first list, this is the second list. Okay. So again, length is same, length is not 1. So first return statement from the first call. Return is first of X into last of Y. First of X is 6, last of Y is 3.
18.
So 18. Plus do something of rest of X, init of Y. Rest of X is 5, 4. Init of Y is 1, 2. Okay. Now control shifts to this. This is the second call. Here now you have again length is same but not 1. So return statement is first of X into last of Y. What is first of X? 5, last of Y 2.
10.
10. Plus do something rest of X. Rest of X is 4.
4.
Init of Y is 1. Now third call. Third call here, directly we can see that length is 1 for both lists. So we'll return first of X into first of Y. So this returns 4 into 1, that is 4. So 4 goes back here. 4 plus 10, 14. 14 goes back to this call. 18 plus 14, 32. This goes back to the first call here. So 32 minus 32, answer is 0. This is clear for everyone?
Yes, ma'am. Ma'am, here this do something L1 comma L2 while performing that, like at the end, the list will become empty, right?
At the end, list will not become empty. List will have one element. Both the lists will have one element.
Okay, I mean it will be reduced, right? L1, L2, the original list.
Yeah.
So
Hmm.
so in the second this after the minus, do something L2, L1. Won't there be any effect?
So what you're saying is correct. That you are saying that these are uh changes that are happening in the lists itself, right? So
Yes,
that's
ma'am.
the thing. See, I am passing the lists as arguments. I am not changing the original lists.
Okay, okay.
Okay. So when it comes out, this scope is just inside this function. The scope is not global. These lists don't change.
Oh, okay, okay. Okay, ma'am.
See, if I saved this, like L1 is a result of whatever is happening and do something L1 L2, then it would change. But L1 L2 are as it is. The only changes happen inside the procedure. So this part will just return the value. It will not affect the original lists.
Okay, okay, ma'am.
Ma'am, please explain that question again.
He is asking that if I am changing L1 and L2, they are getting reduced. The numbers are taken out, removed after every iteration, right? So when I call this do something second time, how am I acting on these two same lists? It's because I am not changing the original list there as it is. I'm just passing them as arguments to this procedure. Okay. So whatever changes happen in this procedure, it is in the scope is just inside the procedure. It is not the scope for the whole program. So whatever changes happen here do not affect the original lists, which are outside of this procedure. Okay. These are local variables.
And I got confused after the last line.
Which line?
After 12th line.
This is just ending the procedure. See, it is a separate procedure. This procedure do something. This does not change L1 or L2 lists. Okay, these are in the main program. This program is calling this do something procedure. So whatever changes happen inside this do something procedure, it does not affect the original lists. This think of it as just a copy of these lists that are getting worked upon. Okay, so you just have to check that what this procedure returns once by taking L1 as the first list, L2 as the second list, and then vice versa. Okay. Anyone else who doesn't understand this?
हेलो मैम मैम 10 कहाँ से आया मैम वो 10 और 28
Which one?
10 प्लस 3,6 तो वो 10 कहाँ से है
This 10.
यस मैम
So, see, we were working on this part, right? Do something of 2, 3 and 6, 5. So length is not equal. This one fails. Length is equal. But is length of both lists equal to 1? No, both lists contain more than one element. So you will have to come to the last return statement, which is saying first of x into last of y. First of x is 2, last of y is 5. So 5 into 2, 10 is 10. Plus again call do something with rest of x and unit of y. So now only one element left. So you can directly return this statement. First of x into first of y. So 10 plus 18, 28. You have to calculate the whole thing in a particular call before backtracking to the previous call.
ओके मैम
So this pseudocode is executed using scores dataset. What will CTD of K represent at the end of execution? So CTD is what it is, a dictionary, empty dictionary. Right. Again, we are working with the scores dataset. So while table 1 has more rows, read the first row in table 1. If is key, CTD, X town city. So first card you have picked. Now you check that the city town mentioned in that card, is it already a part of this CTD dictionary? Okay. If it is a part, then is key will be, if it is already a key of CTD, is key will give true. So if true, then you go to the next nested if. There are 3 ifs, right? So 2 times nesting has been done. So second nested if is saying is key CTD, X town city, and gender. So that means what? From this, if I'm checking that if this current card's gender is a key of CTD X town city dictionary, that means it is a nested dictionary. So let's say my first card is Kolkata. Okay, and it is a girl's card. Okay, let's say the physics marks is 98. So this is the first card I've picked. In that case, CTD dictionary is empty. Right, so is key. First is key. Will give true or false? Is Kolkata a
False.
key of
False.
CTD? False,
False.
right? So I will not engage further into these if statements. Instead, I will come to the else part. Okay, that is this else. So that means I have to create the key value pair. So now in CTD dictionary, I have a key for Kolkata. Against that, say there is an empty dictionary stored as the value. So dictionary inside dictionary. Now in this empty dictionary, what am I storing? Gender is a key and the physics marks is a key.
Ma'am, physics marks is also
Physics
a
marks is
key.
a value.
Yes,
No,
ma'am.
it is a value. Sorry. Gender is the key. Physics marks is the value. So inside this, now the gender for this card is F. So that's the key. And the value is the physics marks, that is 98. So this is the first entry. After this, if you get one more card, let's say also from Kolkata, and this is a gender male and physics marks is, let's say, 90. Then you will again check that is this Kolkata already present as a key in CTD dictionary. Now you get true value. So this is key is correct. This gives true. So next nested, if you check here, the current gender of the card is that a key of this particular city, Kolkata. So is male
False.
already a key? No. So come to the else part here. So now this dictionary will be again updated. So now you have a new key value pair for this city, Kolkata. So for that particular gender male, this is the first card you have picked. So now this is CTD, right? Next, if you find one more card from Kolkata, let's say, this is also belonging to a male student who has scored, let's say, 92 in physics. Okay, now first you check, is Kolkata a key? Yes. Second if statement, is the gender already present in this key, in this dictionary, nested dictionary for Kolkata? Yes, male is also present. So now the third nested if, whatever marks are stored against that gender correctly, which is 90, is that less than the current card's physics marks, which is 92? So 90 less than 92. This is correct. Then the marks will be updated. So now this becomes 92 instead of 90. So from here, what can we say that CTD of K? In this case, let's say CTD of Kolkata. What does this represent? See, if I get a
CTD
female
of
student's
Kolkata.
card who scored 99 in Kolkata physics marks, then this will also be changed to 99. So regardless of whatever gender it is. So what does this part represent actually? Which option?
Ma'am, maximum marks in physics for both.
Ma'am, this CTD of Kolkata, is it? Then it will have two keys
Yes.
of
See, for
male and
every
female.
city, we will have only two keys in the nested dictionary, one for male, one for female. And what is being stored against those two keys?
And maximum physics
Maximum
I
physics
think it would
marks
be option B.
among the
Max physics marks scored by that particular gender in that city, right?
Yes, ma'am.
First option is saying a dictionary with gender as key map to physics marks. Is this correct? This is partially correct. It is a dictionary with gender as key. CTD of Kolkata, this will represent this in a dictionary. It has gender as key and it is mapped to physics marks, but we have more information to represent. So a dictionary with gender as key mapped to the highest physics marks scored by that gender in that city.
Yes.
This is the correct option. C is wrong. Why? Because lowest we are not checking. Dictionary with cities as keys mapped to physics marks. This is also very wrong. So only option B is correct. This is clear for everyone?
Yes, ma'am.
Yes, ma'am.
This is also a question that has come many times in different variations, this particular question. So consider the dictionary CTD that we created in previous question. What will A and B represent at the end of execution? So now on that same dictionary we created. Here A is set to 0, B is set to 0. For each I in keys of CTD. So keys of CTD first of all is what? It is a list of cities.
Jane.
Right. CTD is the whole dictionary. What are the keys of that dictionary? Cities. Against each city, again another dictionary is stored. Right.
And gender.
Ma'am,
Gender is
L,
it is if I say city D of some city, Kolkata or Delhi or whatever, then you get a dictionary nested where the gender and the physics marks are present. If I say keys of the dictionary itself, this dictionary, what are the keys? Kolkata, like this for other cities also.
This name of cities.
Okay, so
unique
each city.
city.
Now, L is what? Keys of city D of I. That means this I is what? Some city. Right. Let's say the first city is first I, for each I in keys of D, first I, let's say, is Kolkata. So what are the keys of city D of Kolkata? Keys are always going to be same, male and female. Right. So L is
Ma'am, it can have only one element also, right?
if a city has only female students or only
Yes,
male
ma'am.
students, then it can. But in our data set, every city has both types of students. So you can consider that it will have two keys.
Okay.
Okay. So M and F, these two keys are going to be there in L. Now, if first of L is M, so either M is going to be present as the first element or the second last element, whatever. If first of L is M, so here first of L is the gender male. Then you check if city D of I, that means for city D of Kolkata, first of L, that is male. So this turns out to be city D of Kolkata and gender male. Whatever value is stored, that is the highest physics marks, is that greater than city D of Kolkata for female? Say last of L. Last of L is obviously the other gender, female. That means have males scored higher physics marks than females. Right. This first of L contains what? Highest physics marks scored by males in Kolkata. Last of L is highest physics marks scored by females in Kolkata. So have males got the higher marks as the highest physics marks or females? If males have the higher marks, then A is incremented. Else, see, this else I will come to if the first of L is not L. It might also be right that I stored the keys in this order. This is also fine. So if I say the first of L is female, then I'll directly come to this else statement. First of L is not M, it is else. Now I'm checking that city D of I, first of L, that is female marks for Kolkata. If it is greater than male marks, then B is implemented. So A represents what? B represents what?
And both the statements are same.
No. A gets implemented when males from a particular city have scored a better highest marks in physics than females. Let's say in Kolkata, highest marks scored in physics by 90. So it means it is implemented. In Delhi, let's say, female students scored highest physics marks 95 and male students scored highest physics marks and they will get implemented. So it is number of cities where the physics highest marks scored by male students is greater than that of females. And B represents the number of cities where the physics highest marks scored by female students is greater than that of males. Is the explanation clear?
Yes, ma'am.
Yes.
So which option from here? Tell me.
Option A.
A.
Option A looks correct. Why not option B? Because first of all, it is not number of students,
Yes.
right? But number of cities.
Is from the front.
So from that reduction only, you can eliminate B and D. The real comparison is between these two options. C is wrong by number of cities from which female has scored higher. Wherever female is scoring higher marks, that is being counted in B variable, not A. So this is correct option. Okay, this is also a very simple question.
Ma'am, how it is clear from the code? These two statements are exactly same. If city of DI
Statements are
fifth
exactly
and
same.
10th.
But in which criteria am I using the statement? The first statement in line 5. This is executed when the first of the list is M. That is,
Yes, ma'am. Yes. Okay,
we
ma'am.
are comparing for males first.
Yes,
If it
ma'am.
is not a male, then we go to female. See, the first of L means different things in both contexts. Here it means M, here it means F.
Yes, ma'am.
Ma'am, A plus B will be less than length of L there.
Length of L is just 2,
Length of
right?
CTD, length of keys of CTD.
Length of keys of CTD is what? Number of unique
Unique.
cities.
Yes, ma'am. It should be less than
Right.
equal to, right?
So first you see A and B. Okay, let us take these as two sets.
There
Are
might
these
be
two sets going
some,
to intersect anywhere?
I guess there might be some cities where like same
Where both
marks.
might have scored the same marks, yes.
Yes,
So they
ma'am.
don't fall under A or B,
Yes,
right?
ma'am.
But A and B sets do not intersect at all. They are disjoint sets. So A plus B has to be strictly less than or equal to length of CDD,
Yes, ma'am. Okay.
length of keys of CDD.
Okay. Okay, ma'am.
Okay, this question is saying the given pseudocode is executed using a data set having the same fields as the words data set. Okay, so it is not exactly our data set, it is a similar data set as to words data set. So the question is, the paragraph given is this: I ordered this product from Gitar. So this whole paragraph is given. Consider two things. First is unique L is a procedure. Again, that same unique L procedure which returns what? Unique elements of list L. For example, if I give this list, think like toppers think, it will return think like toppers. See, only the first thing is preserved, right?
Yes, ma'am.
Now, second one is common number L1 L2. So common number procedure, it takes again two lists and it returns the number of common elements. So if two lists have two common elements, it will just return the value 2. Okay, not what those common elements are, just the value, number of common elements between two lists. 3 is ignore upper and lower case. So again, case sensitivity is not there. So there is something called a positive list, which has a list of positive words, you can say. Sen, that is positive sentence. This variable is set to 0. L is an empty list. Now, while table 1 has more rows, so you will read one word at a time from this given paragraph. Okay. So read first row X in table 1 means the first word from this given paragraph. And every time you read a word, you are appending it to L, list L. Then you are checking if the word ends with a full stop. So when we are at the end of a sentence, then this part executes, otherwise it doesn't. Okay. Otherwise, you just move the current card to table 2 and move on. So whenever I reach the end of a sentence, then what am I checking? L is now containing unique of L because all the words from this particular current sentence is in list L right now. If I do this unique procedure over L now, so it will return the list of unique words in L or unique words in the first sentence. That is now stored in L. What's count is what? Common number of positive list and L. That means current L list contains what? Unique words from current sentence. So among those words from current statement and the positive list that is given to us, how many common words are there? That means how many positive list words are also present in current sentence. That is your positive count. If the positive count is greater than equal to 2, then we can consider this current sentence as a positive sentence. So positive sentence variable gets incremented by 1. And again, L list is emptied out. It is a new list so that you can start reading the next sentence. So you can understand that positive sentence variable is going to get incremented when we find such a sentence which has more than at least two positive words from this positive list. right? So what they are asking us to do is what will be the value of positive sentence. So we have to read the sentences. First sentence is, I ordered this product from Gita. Okay. So this L, unique L will contain which words? All 6 words from this sentence because there are no duplicates, right? All 6 words, I ordered this product from Gita. All are unique. Now check that within these 6 letters and this positive list, are there any common elements?
No, ma'am.
No, right? So positive count, this will return 0. So is this a positive sentence?
No.
Positive count is not greater than equal to 2. So this is not a positive sentence. So percent remains 0. Second sentence, I am very happy to share. So first of all, very. It is not a positive word, but happy is a positive word. It is present here, right? So for this, pause count increases, right? Now pause count is 1. To share my review regarding this awesome product. So awesome is another word which is in common with the positive list. So from this sentence, how many positive words we found? 2. Pause count is 2. So is it greater than equal to 2? Yes. So I can consider this sentence as a positive sentence. So percent will be incremented by 1. Now percent variable is 1. That is, we have found one positive sentence so far. Third sentence, it is not only nice. Nice is again part of the positive list to use, but also has a very cool look. Cool is also part of the positive list. So again, this is having pause count 2, which is greater than equal to 2. So pause sentence is again incremented by 1. We have now found 2 positive sentences. Now last sentence. I think this is the best. Best is also a positive word. Product which can be bought in this price range. But no other positive words are there. So only 1. Pause count is only 1. 1 greater than equal to 2 is wrong. So how many positive sentences we found in this paragraph? 2
2.
positive sentences. So you are returning what? What will be
Oh,
the
sorry,
value of
2.
positive sentence?
No, 2.
So the answer is 2. Same, you can get a question regarding negative sentences. So a negative list will be given. You have to find out how many common elements. Or maybe both will be given, positive and negative list, and there will be a bigger paragraph. So you'll have to check that which sentence falls into what category, or if there are some neutral sentences. Right. This is clear for everyone?
Yes, ma'am.
So now 10 and 11 are comprehension questions. Okay. So A and B are positive integers. Procedure remainder A comma B returns remainder if A is divided by B. Okay. So if I pass here 5 comma 2, this will return what? Remainder procedure will return 1. 5 divided by 2 is giving remainder 1. So procedure do something X. This takes some X. J is set to 2. Flag is set to true. If X is equal to 1. So here we could have mentioned one thing that X is some integer, right?
Ma'am, here it is written that if A is divided by B, I mean, what does it mean? Like, if A is not divided by B, then won't it return the remainder?
It will return the remainder if A is divided by B. That means whatever A is, when I divide it with B, whatever remainder is there, that will be returned. So if it
Okay,
is 4
okay.
comma 2, then remainder is 0 will be returned.
Is there any case where A is not divided by B?
Not divided means? See, 2 does not divide 5. That's why we have a remainder.
Oh, okay, okay, okay.
Okay, it is just a way of writing that if A is divided by B, then it returns the remainder, whatever is remaining after the division.
Okay, okay. So remainder 2 comma 5 would return
Yeah,
what?
like if you just do it in the reverse way. If I try to divide 2 by 5, so it doesn't go. So 2 will be the remainder itself.
Okay, okay.
And if I divide 5 by 2, then 2 to the 4, only 1 is remaining. So 1 is the remainder. Similarly, if you put something which is divisible by 2 completely, then 0 is remainder.
Okay, ma'am.
So x is some number, j is set to 2, flag is set to true. If x is 1, directly return false. If x is not 1, then I will continue with this while loop. So now j is 2. Okay, let me take some arbitrary x. Let's say x is 7. Okay, any x I can take. So if x is 7, j is 2. So 2 less than 7, correct. If remainder of x comma j is equal to 0. So remainder of 7 comma 2 is what? 1, which is not 0. So
Yes.
if statement is wrong. Okay. So here I will just increment j. So j becomes 3. Next iteration, 3 less than 7, correct. Remainder of 7 comma 3. This is again 1. 3 to the 6. 1 is remaining. So again if statement is wrong, j is again incremented to 4. Remainder of 7 comma 4. This is remainder is 3. Again j is incremented to 5. Remainder of 7 comma 5. This is 2. Again j is incremented to 6. So remainder of 7 comma 6. This is again 1. And lastly, now j is incremented to 7. But 7 less than 7 is breaking the while loop condition. So we'll come out and we will return whatever the value of lies. So for this particular value of x, was flag ever set to false? Flag would have been set to false if we found such a j which divides x. Completely divides x. There is no remainder other than 0. But did we find any such j value? 2, 3, 4, 5, 6. None of these completely divide 7. So flag remains true as it was said in the beginning. If instead of 7, I had taken 8. Okay, then in the first iteration itself, it would have been 2 is less than 8, correct? Remainder of 8 comma 2. 8 comma 2 will give what remainder? 0. 2
0.
completely divides 8. In that case, flag is set to false and we exit the loop. That is, no more iterations will happen. And I will directly return the value. So now flag is set to false. So what can I say about this? About x? If I see that flag is returning true value for some x, what can I say about that x?
X is not a prime.
If
Oh,
flag is
sorry.
getting
X
true
is
value,
a
then
prime.
x is a
X.
prime.
Yes,
Correct.
ma'am.
Because prime only gets divided by itself and 1, right? That's the only, those are the only numbers. And whenever a number is getting divided by itself, that cannot be checked here because j always has to be strictly less than x. So we are basically checking that if a number gets divided by anything starting from 2 to the number minus 1. Right? That is all the possible factors of the number. If nothing divides it, then it's definitely a prime. That means if flag gives true at the end of execution for any x, that means that x is a prime number. So what will procedure do something x? When will it return true if x is a prime? Part question. Consider the procedure discussed above. What will the value of m be at the end of execution of this procedure, this pseudocode? So L is now given to us. M is some empty list. Position is set to 0. Position means index basically. For each element in L, so I'll start with 8. If do something position means do something is a previous procedure we did. So that procedure returns true when x is a prime. So first x is 8. So do something of 8 will return what? True or false?
False.
Because 8 is going to get divided by 2, 4, many numbers. So it will not return true, it will return false. Do something of 8 will give false value. And do something of, do something of position, right? So this is 0 actually. The first position is 0. I'm doing first iteration. Let me number it. First iteration, if statement, do something of position that is 0 and do something of element which is 8. So for 0, okay, for 0, what will happen? See the do something procedure. Here when x is 0, in the while loop, will I be able to get inside the while loop at all?
No,
Because
ma'am.
j starts from. So
Same
in that
will like same happens for 2 also, right? You won't enter the while loop.
same happens for 2 also. So only for 1 it is being accounted that if I get 1, I'll directly return false. But what happens for 2? For 2 also you have to directly go here because 2 is the first prime, right? So
Yes,
you will
ma'am.
definitely return true only. For 0, what happens? For 0, we don't have any provision here, right? So 0 is not falling under this if statement. 0 is not going to be checked in the while loop. So it will also return true only. In the return statement, it will just return the flag value. So flag was initially set to true. So it will just return true for 0. Okay, it is also treating 0 as a prime. Although we cannot say it that 0 is a prime number, but this procedure is treating 0 as a prime. So here ds of 0 will return true, but ds of 8 will return false because 8 is not prime. So true and false will give what? False.
Yes, ma'am.
So if false, the entire thing gives false, then will I add element, the current element to M list? No. I will simply increase the position 1, that is the next index. Okay, so now position is 1. So second iteration, if ds of 1 and what is the next element? 12. ds of 12. So again for 12 only I can check that this will give false and ds of 1 is also going to give false because we had that if statement. If x is equal to 1, return false directly. So false and false again, M list remains empty. It does not get filled with any elements. Next position is 2. So third iteration, ds of 2. What is the next item? 13. And ds of 30. So ds of 2 will give what? Smallest prime.
True.
This will give true value. 13 is also a prime. This will also give true. So true and true, both are true. Now in M list, I'm going to add the current element, which is 13. Next position is 4. So fourth iteration, if do something of 4,
It's
and what is the
false.
next element? Wait, it is 3, right? Not 4. 3. Do something of 3, and the next element is 23. So ds 3 is also prime, so true. 23 is also prime, so true. So
Yes.
23 also gets added to M list. So it becomes 13, 23. Next position is 4. So fifth iteration, if ds of 4, I don't need to check the rest because 4 itself will give false. So whole thing becomes false. Next position is 5. So sixth iteration, ds of 5. And what is the next element? So previous one was for 11. We didn't check this because ds of 4 itself will evaluate to false. Next element is 40. So ds of 40. This will also return false, even though this gives true. So true and false is false. So nothing else gets added to this. So M at the end of execution has 13, 23. So option D should be correct. Is this clear?
Yes.
So what
Yes,
is
ma'am.
M basically? M is just checking that wherever the position or the index is prime and the value stored is also prime. Only those values we are picking. See, index 0, 1, 2, 3, 4, 5. Among these, how many elements are there which are prime and present at prime index? 13 is prime, present at prime index 2. 23 is prime, present at prime index 3. Others are not, right? First, 8 is not a prime, 12 is not a prime, 11 is a prime but at a non-prime index. 40 is a non-prime at a prime index. So these are not considered, only these two. Question 12 is for 6 marks. So
Ma'am,
for
your
the
voice is not clear, ma'am.
Oh, ma'am, it's clear.
Now it is clear.
Yes, ma'am.
So for words data set, consider a scenario where we want to find the number of sentences containing at least 10 distinct letters. Okay. So we are considering a scenario where we want to find such sentences, number of such sentences that contain at least 10 distinct letters. We asked ChatGPT to generate the pseudocode for this task. Okay, so two different pseudocodes are generated by ChatGPT. This and this. Which of the following statements is or are correct? Okay. So let us first check that is a part to this one. No, this is not part question. Okay. So first let's check the two pseudocodes. First pseudocode is saying, remember the goal is that we need to find number of sentences that contain at least 10 distinct letters, not words. Count is 0. L is an empty list. I will go through words data set one by one, right? Each card. And what am I checking here? Read the first row accent table 1. L, inside L or empty list, we call the add something procedure, which takes the list L and the current card X as input. So what does add something do? It takes a list and a card. And then I is set to 1 as long as I is less than equal to letter count. So P is ith letter of the word. That means we are going through every letter of this Y word. If the current letter is not a member of M, that is the list, okay, then you add it as a member. Member is what? It is a function that checks whether an element is already a member of a list or not, right? So if member gives false, that means P is not a member of M. So not of false will give true, right? If we find such an element P which is not a member of list M, then we add it to list M. Otherwise not. Okay, because we are trying to find what? Unique letters. So from the current card, the current word, we are trying to see that how many letters am I getting, right? All those unique letters are going to be stored in list M, which is nothing but list L. This is just the argument we have passed, right? So like this, then I is getting incremented. So you go for the next index or the next letter in the word. So how long will this continue? As long as I reach the letter count of the current word. So I will check every letter of the current word one by one, and then every unique letter should be present in the list L. Okay, M is nothing but list L. So this will happen for every word until I reach the last word of a sentence. Okay, so again, let's see with an example. If this was my sentence, I am a student, then tell me in L list, what are the unique letters I will have? I, A, M. This A, will it be considered?
No, ma'am.
S, T, I will have U, D, E, N. That's it. Right. Now next word ends with a full stop. This last word ends with a full stop. Now I have to check if length of L is greater than equal to 10. So here I can see length of my list is 9. So 9 is not greater than equal to 10. So count will not be incremented. Why? Because I am looking for such sentences which have at least 10 distinct letters in it. Okay. If here I had this, I am a girl student, then from girl itself we will get 3 more letters. Now it is greater than 10. Right. So this is a sentence which has more than 10 distinct letters. So it will be considered under count. And see, after we reach the end of sentence for every sentence, L is again refreshed to a new list. So I can go and read the cards for the next sentence. Okay. So this procedure that we saw, is this correct implementation?
I
This
think
first
it is.
looks correct. Okay.
Yes,
So let's see what pseudocode 2 is doing. Again, count is 0, L is empty. As long as we have more rows in table 1, read the first row. Again in L, call the add something procedure. In add something procedure, see again it is taking empty list and the word I set to 1, I less than equal to letter count, P is ith letter of word, if not member then add P. Same thing is happening, right? After this here, if here the change is there, see, it was asking here if X word ends with a full stop, then you check if length is greater than equal to 10. Here it is saying if X word ends with a full stop and length of L is greater than equal to 10. It is the same thing, just instead of using two if statements, they have written in the single one using this conjunctive. So X word, if you are at the end of a sentence and the length of list L is greater than equal to 10, then count is incremented. L is set to empty list. So is this correct or not?
This
Check
is
the
not
two
correct
codes. Why it is not correct?
because reinitialization of L is in
Should happen regardless of whether this is true. Correct.
Yes.
This
Also
should
after
not
line
happen
8.
inside the if. Right. This should not happen inside the if. It should happen outside of this if statement, because this statement should happen. This should execute whether or not the current sentence is fulfilling this greater than equal to 10, this criteria, right? Because our goal is that we will check every single sentence individually. So L has to be reinitialized to empty list after every sentence. And this will only reinitialize L when we find such sentences that have more than 10 unique letters in it. So this is wrong. So now the options are saying both pseudocode 1 and pseudocode 2 will give same required output. This is definitely wrong. Pseudocode 1 produces a desired output, 2 does not. This is correct. And if this is correct, option C has to be wrong. Option D is saying both pseudocode 1 and pseudocode 2 will not give the required output. This is also wrong. Pseudocode 1 is giving required output. E is saying for pseudocode 1, if any sentence contains more than 10 distinct letters, 10 distinct, they have written integers, this should be letters, okay. List L will not be reinitialized to 0. This is wrong. List L always gets reinitialized to 0, whether or not the current sentence has 10 distinct letters or not. So pseudocode 1 takes care of that. Here, the reinitialization is not subjected to the if statement. So this is correct. For pseudocode 2, if any sentence contains, oh, okay, this is wrong. Sorry, they are saying it will not be reinitialized. For pseudocode 2, if any sentence contains less than 10 distinct letters, list L will not be reinitialized. This is correct. That's why pseudocode 2 is wrong. So option B and option F are correct. Yeah. This is clear for everyone. Only one small difference between the two codes, but very important difference is this. This should not depend on the if statement. This should happen regardless at the end of every sentence.
Yes.
Okay. This question is saying, following pseudocode is executed using library dataset. At the end of execution, A stores a dictionary with author's name as key and number of books written by him or her as the value. But the code may have mistakes. We have to identify all the mistakes. So A is empty dictionary. What is our goal? That A should store a dictionary with author's name as key. All the keys are distinct author names. All the values are number of books written by that author. Okay. So while table 1 has more rows, this is we are going through the library dataset one by one. So read the cards. If not of is key will give true when this author is already a part of dictionary A. If he is not a part, then not of is key will give true, because is key gives false, not of false is true. So if we find a new author, then we first create the key value pair. Right? So if not of is key, if this is true, then we should create the key value pair instead of adding. Right? If we are encountering an author for the first time, then we should create the key value pair first. That for this author, let's create a key and let's assign the value 1. Later, if you again encounter this author, then you can increase the frequency. So what is wrong here? This line should come here, this line should come here. Right?
Yes, ma'am. Just interchanging the line will make it.
Interchanging 5 and 8, these two lines, we can get the correct code. The first option is saying replacing the condition given in line 4 with the statement given below will provide correct result. If key A, comma, it's not author. Yes, this is also a solution. Here, if I remove this not, that is, if the author is already a key, then you add a frequency. If they are not a key, then you create the key value pair. This will also fix the code. This is correct. Replacing the statements given from line 4 to 9 with the statements given below. That if not is key, then you create the key value pair. Otherwise, just but see here else is not present, right? That means this increment will happen all the time. That means if I, let's say, if I first find a book by this author, whoever is the author, I find this first book. So I create the key value pair like this. Then I come out of this if block and I again increment, right? Because see, it is not under some else statement, it is just a statement. So this will execute every time. So for one author, once I'm creating the key, I'm also adding another frequency. So for one book, I'm adding two values. This is not correct. This second part should be inside an else statement, right? Interchanging, so this is wrong. Interchanging like 5 and 8 will provide correct result this time already. So,
Ma'am, your voice is not clear, ma'am.
sorry.
Yes, ma'am.
Now it is okay.
Yes, ma'am. It is clear now.
So interchanging lines 5 and 8 will provide correct result. This we already saw. Just change these two lines. Last is replacing the statements given from line 4 to 9 with the statements given below will provide the correct result. That means if not of is key, that is this author is currently not a key, right? Then I create the key value pair, but see, I have found this author, that means I have found one book by this author. So I cannot issue the frequency as 0. Frequency should always start from 1, right? That this author has written at least one book. That's why he has occurred in the library data set. I have gotten a card for it. So this value should be 1. Otherwise, you increase the frequency if they're already an author, if they're already a part of your dictionary. So this is also wrong. So the correct options are option A and C, I think. Yeah. Why B and D are wrong, everyone understood?
Yes, ma'am.
Okay, now some graph related questions. These are very important for interim. We'll definitely get 2 to 3 questions from graphs, which will have good amount of marks. So don't leave these questions. So let M be an adjacency matrix of a graph G given below where Mij is equal to 1 if there is an edge from I to J. So like if I ask you here in this graph, M30, should it be 1 or 0?
1.
1, because 3 to 0 there is an edge. Right? So in the procedure update matrix, we take this adjacency matrix M. We stored this in a temporary matrix because we do not want to change any values in the original adjacency matrix. So we're just creating a copy of it, right? Which is temp mat. Now for each I in rows of M, again, rows and columns of M are always same, right? It is all the nodes in the graph. So for each I in rows of M, for each K in columns of M, if M of Ik is equal to 1 means that there is an edge from I to K. Then again you have a for loop. For each J in columns of M, if M of Kj is also equal to 1, that means K to J there is an edge. Then I can say in temporary matrix, I can set the cell temp mat of Ij to 1. That means if I can go from I to K and from K to J, then I definitely have a route from I to J. Even though it is not direct, it might not be a direct route, but it is a indirect route. Via K, I can reach J. So temp mat of Ij will be set to 1 when there is a route from I to K as well as from K to J. Now, based on the above information, that is see here, 3 to 2, there is no direct route, right? But I can go from 3 to 0 and 0 to 2. Since this exists, that's why in temp mat for 3, 2, we are going to set the value as 1. That is, there is a root from 3 to via 0. So question 14 is asking what the values of P and Q will be. What will the values of P and Q be at the end of execution of pseudocode given below? So new matrix is calling the procedure update matrix. Update matrix does what? This. Okay. So after this is done, what will be temp matrix looking like? We will see that. In P, we stored the value of 3, 1, I3, J1 in whatever is stored in new matrix. So first of all, see, in the update matrix procedure, which values will change? Like I gave you one example. In the original adjacency matrix M, there is no edge from 3 to 2. So matrix of 3 to that value was till now 0. Once you call update matrix procedure, it will now set in temporary matrix the value 3 to 1. Similarly, there is no edge from 2 to 4. But in temporary matrix, what will be the value? 2, 4.
One.
This value will also be 1. Because I can go from 2 to 1
Yes,
and
ma'am.
1 to 4.
Yes.
Same for 4 to 2. Same for 5 to 3. All these values are now updated in the temporary matrix. And see, that's what this update matrix procedure returns, the temporary matrix. So this temporary matrix is the one which is this new matrix. Because inside new matrix variable only, I've called this update matrix procedure. So now for 3, 1, what is the value stored in temporary matrix? That's what they're asking. See, for 3, 1, am I able to find such a route via an
Uh,
intermediate route?
There is a route, but you have to
But
go
it has
through
2
two.
nodes.
Yes, ma'am.
Yes. But here I'm only checking for one link. I to K, K to J. This
Ma'am,
K.
it's a one
Is there
hop path,
such
right?
K? Yes. But is there any such K here for 3, 1
No, ma'am.
via which I can reach? If there was this edge, then I could have reached. Right. So for 3, 1 in temporary matrix, what is the value? 0 or 1?
0.
0.
It's 0.
Ma'am, but we can reach 3 to 1 via 0 and 2.
Yeah, but is that the same thing as this update matrix code is doing? This code
No,
is
it's
checking
2
if
hop.
there is a single node, right?
Yeah,
There
yeah.
are codes in previous years that you can find where we have also taken 2 node paths. Okay, so that's why you have to read this update matrix procedure carefully. There might be 3 node paths also, but here it is not valid. We only want a 1 hop path. So for P, the value will be 0. 5, 1, let's check. For 5, 1, is there a path? 5 to 1 can I reach? Yes. 5
Yes,
to 2,
ma'am.
2 to 1. So for 5, 1, the value will be 1. So which is the correct option? P0, Q1. Okay, this is 4 marks just for this much work.
Ma'am, in the original matrix M,
Hmm.
if we have 1 in an entry,
Hmm.
like so then in the new matrix, this update matrix, we will also have 1, right?
Yeah, see, whatever values were there in the old matrix, wherever 1 was present in the original matrix, those ones are all preserved. Other than that,
Okay,
also
okay.
now some extra ones are present because of the 1 hop paths.
Okay, okay. Okay, ma'am.
This is also from that same question. New matrix 1 is update matrix M. New matrix 2 is update matrix of new matrix. So now you are coming to that 2 hop path. Understood. First one, this one is creating the 1 hop path. Now again, if you call this update matrix procedure on this new matrix, that is creating a 2 hop path. The one that you are talking about. Because see, in this new matrix also, now there are some new edges that have been added, right?
Yes,
So
ma'am.
first of all, let's figure out that what is the new matrix. Okay, so I will just quickly write the new matrix for this graph. Let's create the adjacency matrix. New matrix. So I will just create the old matrix first. how many nodes we have? 6. So 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. So 0, 0, there is no path. 0, 1, so the center is 0. 0, 1, there is no path. This is 0. 0, 2, it is 1. 0, 3, it is 0. 0, 4, it is 0. 0, 5, also it is 0. 1, 0, it is 0. I'm creating the original adjacency matrix first. Then I'll do new matrix 1, then new matrix 2. So 1, 0, there is no path. To 1, where do I have an edge? To 4 only. Only one edge is present. All others are 0. Direct edge. For 2, how many edges are present? 2 edges. 1 and 3. So this is 1, 1, 0, 0. For 3, how many edges? Only one edge to 0. All others are 0 values. For 4, there is only one edge to 5. So 0, 0, 0, 0, 0, 1. And for 5, only one edge that is leading to 2. So 0, 0, 1. This was the adjacency matrix. Now first I create new matrix. That is how many newer paths have I found via some node. So first let's check for 0. From 0, where all can I reach? Via one node, I can reach node 1, I can reach node 3. So for 0, now 0, 1 and 0, 3, these two entries are also 1. Next for 1, from 1 I could just reach 4, but now I can also reach 5. So this entry is changed. This is also 1. For node 2, I can reach node 4 also directly. I can also reach node 0 directly. So 2, 0, 2, 4. Any other nodes I can reach? No. So 2, 0 is also 1, 2, 4 is also 1. This is new matrix now I'm creating. For node 3, I can reach node 2 directly. Right. Previously, I could only reach node 0. So node 2 is now having entry 1. So 3, 2 entry is 1. For node 4, I could reach 5 directly. Now I can also reach 2 directly via 5. So for node 4, this 2 entries now set to 1. And finally, for node 5, I could only reach node 2 directly. Now I can reach 1 and 3 as well. So 1 entry for 1 and entry for 3 are also updated. So this is the new matrix. Now you are passing this into the update matrix procedure. That is this procedure. Now we are going to check for what other routes I can explore. Okay. So see for node 0 now if I check. Okay. Let me just take the option that they have given. This question here. So I have to check for 3, 1 and 5, 1. What are the values in the new matrix? So for 3, 1, let's check. For 3, 1 in the current matrix, okay, I could reach from 3 to 1 directly. Not possible, right? But after updating this new matrix again, see, 3 to 0, I have a path. 0 to 2, I have a path, right? So I can go from 3 to 2. This path I have. And from 2 to 1, I have a path. So 3 to 2 is now considered a direct path, right? Because of this matrix. And 2 to 1, there is another path. So 3 to 1 will also be considered a valid path now. This is the 2-hop route. And for 5, 1, from 5 to 1, there is already a path. So in the updated matrix also, this path will prevail. So now both are 1. So this is the correct option. P is also 1, Q is also 1. So when you create the first new matrix 1, that is also adding the 1-hop paths along with the previous direct paths. When you create new matrix 2, this is having direct paths plus 1-hop paths plus 2-hop paths. 3 types of paths are there. So P and Q values are both 1 in the new matrix. So from the graph, this type of question you will get. Okay. question 16 is saying the given pseudocode is executed using words dataset. At the end of execution, A captures the frequency count of the most frequent vowel in the dataset. But the pseudocode may have some mistakes. Okay, most frequent vowel we have to find in the datasets. There are 6 options for this. So we have to find out which steps are wrong. So first we have D, which is a dictionary. A is set to 0. We have to find out what is the frequency count of the most frequent vowel. So we read the cards one by one from our dataset, words dataset. In D, we are calling update dictionary procedure at every iteration, and we are passing D dictionary and X as arguments. Right. So what happens in update dictionary procedure here? We can see I is set to 1. Okay. I will run as long as I reaches letter count. That is, we will iterate through every letter in this Y word. B is considered the current letter. Okay. If B is not a key of D, then B becomes a key of D. It should, if not of is key is true. That means is key is false, D is not a key. So we are creating a key. That means this line should come here and this line should come here. If it is already a key, then you increment the frequency, right? But if it is the first time you're creating a key, you should assign a value, not add the value.
If it was if is key DV, then it would be included.
If is key, then it is correct.
Yes.
So line 16, line 17, these are wrong lines, right? If 16 is correct, then line 17 is wrong. If we are working with not of is key, then line 17 becomes wrong. What else? So if I fix this, then I is getting incremented, and as long as I reaches letter count, I will keep on doing this. So what is this dictionary D actually storing? It is storing the frequency of every letter, right? But I need to find out what is the frequency count of the most frequent vowel in the dataset. So next, once D is updated, okay. So this while loop will finish when for every card I have updated D. So at this point, when this while loop is over, D dictionary contains what? For the keys are all unique letters in the dataset, and the values are all the frequency of each letter. Right. So now a for loop is being run for each key in C, for each C in keys of D. Yeah. So what is each C? Each letter. Now I'm checking if C is a vowel and D of C, that is frequency count of C, is less than A. A is some value. But C,
A was 0 initially, so
A was 0. So no frequency will be less than 0. Right. So this
yes.
statement is also wrong. It should be if it is greater than A, then A gets assigned. Also, this line is wrong.
Yes.
If I'm trying to make A as a math variable, I assign the
append
value. I do not add the value. I just assign the newer, higher value. So let's see which are the line numbers they are given in options. So line 1, incorrect initialization of D. No, D has to be a dictionary. It is correct initialization. Line 8, incorrect conditional expression. Line 8, this is incorrect conditional expression. This should be a greater value. Right. If D of C for any vowel is higher than current A, then you assign that value to A. So line 8 is definitely a mistake. Again, line 9, A is updated with the wrong value. This is also correct. A should be assigned the new value, not added. Line 13, incorrect initialization of I. No. I can be initialized to 1 as long as this equal to sign is there. If I said I has to be less than y or triple count, then you start I with 0. So line 13 is fine. Line 16, conditional expression should not use not operator. So like you said, here if I remove not, then it becomes correct. So line 16 is also correct. This is also a mistake. Line 22, I updated at wrong place. No. I will get updated regardless, whether if or else, whichever one is correct. I has to get updated for the next iteration. So line 8, 9, and 16. These are all wrong. So B, C, E. This is clear for everyone?
Yes, ma'am.
17, 18 again, these are comprehension questions. So consider a graph generated from sports dataset that is represented by matrix B. Each node in the graph corresponds to a student from the dataset. So a graph that is generated from sports dataset, okay, represented by matrix B. That means adjacency matrix. Each node in the graph corresponds to a student from the dataset. Sequence number is used to label the nodes because sequence number is unique for every student. So if there are 30 students in the dataset, there are 30 nodes in this graph. Now the pseudocode is doing what? A is an empty dictionary. While table 1 has more rows, so I will keep on reading each card from the sports dataset. Yeah, and A of sequence number. Okay, so this is the key value pairs being created. So for every student sequence number, what is the value getting stored? A list of the city of this person and the gender of this person. Okay. So for sequence number 1, it might be entirely female, like this. For every sequence number, some value is there. I think sequence number starts from 0. So like this. This is the dictionary A. N is what? Length of, so see, inside the while loop, this dictionary is now populated. N is length of keys of A. Who are the keys of A? The distinct sequence numbers. So as many students, that many sequence number, that is N. So N is nothing but number of students. B is calling create matrix procedure N command. So this is actually creating that adjacency matrix. Right. So B is now a square matrix of order N. Dimension and cross N. For each I in keys of A. Again, keys of A are sequence numbers, right? And for each J in keys of A. If I is less than J, like sequence number 0 is less than sequence number 1. And is related AI, AJ is true. So what does is related procedure do? Come here. So let's say I have two sequence numbers. Let's say I'm working with sequence number 1 and 2. This one is from, let's say, also Delhi and also female. Okay, so this X is sequence number 1, this Y is sequence number. So if first of X is equal to first of Y, that is both are from Delhi, and last of X is equal to last of Y, that is both are female. Then return true, else return false. So for every every possible pairing, we are checking whether they are from the same city town and have the same gender. So we are finding every possible pair of people or pair of students that have the same city town as well as the same gender. Then I will return the value true. So where is this value getting returned? Here. That means for every I that is less than J, like 0 less than 1, 1 less than 2, if I say that A of I and A of J, right, that is these two lists, and I compared them, the first and last elements, if they're same, then this will give true. If both are true, then B of ij is set to 1, B of ji is set to 1. That means then I can say that in the actual graph, so in the actual graph between these two nodes, now a bidirectional edge is present. I can go from 1 to 2, I can go from 2 to 1. When I am sure that 1 is less than 2, that is I is less than j, and I and j have the same gender and belong from the same city, then they have a bidirectional edge between them. So there's an
Here,
edge. Hmm.
sequence number is lesser than the next. I is less than j means sequence
Hmm.
number is lesser.
Sequence number I and j are just representing sequence numbers only. See, for each I in keys of A. Keys of A are nothing but sequence numbers. So I and j are sequence numbers. So for a pair of sequence numbers such that I less than j, like 1 less than 2, if I see that A and I and J, these two sequence number students, belong from the same city and have the same gender, then I will say that bidirectional edge exists between them in matrix P or in the graph.
Is it just reducing the number of comparisons? That's why it's written I is less than J.
I is less than j. So if I didn't give this, okay.
Ma'am, your
This is just a
voice is not
criteria that they
clear.
have. See, I is less than j is just a criteria they have placed. Okay, if this give j is less than I, then
Yes.
also the value will be different now. I mean, the number of edges will change. Right? This is just an extra criteria.
Okay, okay. If
The
we
main
also remove this, then also there at the end we will get the
then
same,
no,
right?
no, no, it will not be same. Okay. See, here the edges depend on this extra criteria that I is less than j. If I remove this, then for any ij, this it will only check the city and gender. So this is actually a smaller set.
Oh, okay, okay, okay.
An extra
So,
condition is placed.
okay, okay. If you will remove this, then I
It's
also, if
just
I is equal to j, then also there
yeah.
would be,
If I
okay.
is equal to j or if I is greater than j for every such case.
Okay, okay.
Okay, so this is saying that there is an age between students I and j with I not equal to j. Okay, I and j different students. When can there be an age between them? If they're from the same city town, they have the same gender. They are from the same city town and have the same gender. They are from same city town or have same gender. This is very simple. See, right? That's the literal condition given. Option 8, question 18 is which of the following statements are true about the above generated graph? So there are two clicks in this graph, one for each gender. First of all, what is a click?
It's like an undirected
Uh,
cycle.
Correct. That means in a click,
Pair
I
of
can go
nodes
from
is
every node to every
connected.
other node.
Yes, ma'am.
In a click, it is possible to go from every node to every other node, right?
Directly.
That's what forms a click directly. So the first option is saying there are two clicks in this graph, one for each gender. Is this correct? When I create this graph, are there only going to be two clicks? And is it gender specific only? See,
No, ma'am.
the people, all the females, let's say there are three female students from Delhi. So these three will come in a click. Okay, if it is like this, that I less than j, that condition also prevails. Let's say sequence numbers 0, 1, and 2. These three people are all from Delhi and all are females.
For
Node
different
0, node 1,
cities,
node.
Okay, okay. So
also
there would
different
be
clicks.
three clicks,
So
three
there would be
C2.
an edge from 0 to 1, there would be an edge from 1 to, there would be
There
an edge
will
from
be
0.
so many clicks for
So
different
this is one
cities.
click. So it is not gender specific or city specific. Both of them have to be correct. As well as this thing that I less than j. This relationship should also prevail. So there are not going to be two clicks. There are going to be many clicks in this graph. In every click, there is at least a pair of students having different genders. Is this correct? Not
No,
required.
ma'am.
In this click only, no one has different gender. And also, you cannot have different gender and be in the same click. Right, because the edge only exists if you have the same gender and are from the same city town. Option C is saying all students in a given clique have the same gender. This is correct.
Yes.
Only then they can be in a clique. Only then there is an edge between the two. All students in a given clique are from same city town. So both of these conditions have to be true together for a clique to form, right? So all nodes in a clique have the same city town and the same gender. There are no cliques in this graph. This is definitely wrong. Clique to form a clique, we should have more than one node. That's the only criteria. So there is definitely going to be at least, I mean, more than one clicks in this graph. So C and D are correct. Click related questions are very important from graph.
Ma'am, could you please repeat the first option, ma'am?
It is saying there are two clicks in this graph, one for each gender. This cannot be correct, right? If I have two clicks, one for males, one for females, is it true that all females or all males will be in the same click? all females, if they're in the same clique, it is not possible, because to be in a clique, they not only have to be females, but should also belong from the same city town. All females are not going to belong from same city town. That means there cannot be one single clique for a gender. There will be multiple cliques. Like this example I took. 3 women from Delhi, so they form a clique. Similarly, 3 men from Kolkata, they form a clique.
Okay, ma'am,
so
I got it.
Ma'am, also within this click 0, 1, 2, like we will have 1, 2, 3, 3 more clicks, right? Of length 2.
means
In the thing
yeah,
you
yeah,
have drawn.
yeah, surely, yeah. 3 more clicks of length to there.
Okay. So
Each click can contain other click. This is also a separate type of question. You will get this type of questions, that how many clicks of size 4 are there in this graph.
okay.
This
Ma'am,
is
how click of size 2 is created in this,
see
for this? Yes.
here node 1 to node 0 to node 1. This itself is a click. Node 0, node 2, this is also a click. Node 1, node 2, this is also a click. That means whenever more than one nodes are connected bidirectionally, it
Yes,
forms a
ma'am.
click.
Yes, ma'am.
Okay. One second.
Ma'am, cliques will also form closed loop structure, right?
Yes. One second. Okay. What are you asking? Closed loop structure. Yes. So basically, first of all, you need to know what is a click, right? A click is a very important concept in your graph theory. It means that it is a subset of vertices in an undirected graph. We always talk about clicks in undirected graphs, not in directed graphs. So click is a subset of vertices in an undirected graph where every distinct pair is adjacent. That means there is a direct path from every node to every other node. So it is a complete graph, complete subgraph rather. That means there might be many clicks inside a click. This is also possible.
Got it, ma'am.
So this is again a comprehension question on graph. So you can see many questions are going to come from graph. At least you will get a good, if it's a 20-question paper, you're getting 5 to 6 questions from graph theory. At least 4 5 questions you will get. Okay, so those last 2 weeks, week 10, week 11, week 9, these are very important. So let M be the adjacency matrix of graph G as shown below, and consider the procedure do something. So graph is given, some procedure is given. What is procedure doing? Do something. It is taking M and Q. What is M? It is the adjacency matrix of this graph. Okay. Q, they have not given what is Q, but I think it is some node. Let me see the questions. It is some node. Okay. So 1, 2, 3, 4, 5, 0. These are all, any of these can be considered as Q. So the adjacency matrix and any node, these two are the parameters of this procedure. Now count is set to 0. For each I in rows of M, that is, we'll go through every vertex. If M of IQ is equal to 1, that is, there is an edge from I to Q, or Q to I there is an edge, then count is incremented. And we are just returning what is count. So for any node, let's say if I pick the node 3, okay, or if I pick the node 2, let's say if I pick node 2, for 2, check with every other vertex. Is this condition true? How many times is it true? So from any other node to Q, are there any incoming edges? How many incoming edges
Yes.
does 2 have? Only 1.
Only one.
So 1 to 2 there is an edge. For this count will be incremented once. Again 2 to other nodes. How many outgoing edges are there? 2. It means 2 to 3 and 2 to 5. These will add. So 1 plus 1 plus 1, total 3. Count will be incremented 3 times. If the procedure was called with the adjacency matrix, comma 2. So then it will return count 3. That is the question. It is asking that for do something in m comma 3. What does this give? So just calculate the number of incoming and outgoing edges. From 3, how many incoming edges are there? 1, 2, 3. How many outgoing edge? 1. So total number of, what is the degree? 4. This is just the degree. Okay, this is just calculating degree of a node. How many
Ma'am,
incoming or outgoing edges are
also here, it is not exactly the degree, I guess, because if there is an incoming edge from 3 to 2, and there is also an outgoing edge from 2 to 3,
there? Yeah, that
then
should cancel out, right?
yes, ma'am, then
That's the
that should be counted as 1, and
Yeah,
but the
but
degree is
that's
one
why I
more.
said that this particular graph is drawn in such a way that it will give you the degree because there are
Okay.
no such bidirectional edges. I
Uh-huh.
mean, no
Okay.
two edges between two nodes that are going in a cycle. No cycles in this graph.
Okay.
So
Okay,
for
ma'am.
3, it will give 4, right? And the second question is that if you pass 2, we already calculated is the value 3. So see, for this you're getting 9 marks. It's taking 5 minutes to solve. So I'll say that first you solve the graph questions when you get the paper. Okay, if possible. Then you go to the pseudocodes. Because later on, if you leave this for the end, these are very easy questions, still you might mess up. Okay, so do these first in exam.
And
This
for
is a
two,
very, yeah,
for 2, how it is 3. For
I'm not
node
able to
2, for node 2, how it is 3.
note to how it is 3. See, from note to how many outgoing edges are there? Only one, only two, sorry.
2.
2 to 3 and 2 to 5. So this will increment count once, this will increment count once. And again from I to Q, that is any other node to node 2. How many edges are there? That is how many incoming edges does node 2 have? Only one. So count will increment it once here also. So 1 plus 1 plus 1, 3. Basically, this question, if you look, it is just counting how many incoming and outgoing edges are there for a particular node Q.
The degree will be the sum of incoming and
Yes.
right?
So in this case, it is the degree. Okay. In this case, it is the degree only. So this is a paper which I took because it is a very balanced paper. This has questions from every important subject. So you can practice this paper once on your own, but for this week, please complete the mock first. I think the
Ma'am,
deadline is on Friday.
ma'am, can you just summarize that last question?
Which one?
The last question, I think question number 20.
This is just the same thing. No? We are just checking for Q equals to 2. That for node 2, how many incoming and outgoing edges are there? The sum of that is simple. Just check this condition. That for any node Q, as long as you find an incoming edge or an outgoing edge, count is going to be incremented. So for 2, we found that there is a 1 incoming edge, 2 outgoing edge, so 1 plus 2, 3. This is, so by Friday, everyone please complete the mock. On Saturday session, then I will take the mock session. Now, the question is that on Friday, do you require any doubt clearing session? Because we have already conducted all our interim revisions. If you have any doubts which you want us to discuss in a session, then we will do that on Friday. Otherwise, we will just skip that and go for the Saturday session to discuss the mock. Okay, that is on you. So one thing you can do is on the discussion forum or wherever it is, you can just discuss among yourselves once. If you have some substantial number of doubts that would need one session to clear, you can just let the TA know and we will ask the TA from the TA session. Okay. If
Ma'am,
you
this
require,
particular pseudocode was like adding up the total number of incoming and outgoing edges of a single vertices, right?
yes,
Okay,
same
ma'am.
thing.
Okay.
So if you require that, we will take that session on Friday. Otherwise, we'll just take the Saturday session to do the mock discussion. That's it.
Ma'am,
Ma'am,
Saturday, can you do it on Friday?
Okay, Friday, I think is the mock submission date. So that thing, let me
Okay,
just
yeah.
check with support team once. If they say that mock is submission by 12 a.m. at night, then I cannot discuss. If it carries some bonus, okay, first I'll check that. If
Okay,
mock is graded, if it is not graded, I will do it on Friday itself. I'll send you an announcement regarding that Friday session. Okay.
okay, ma'am. Ma'am, because on Saturday, like many of us will
Have
not be able
exams.
to attend.
No, right.
Uh, that's
I
why.
will just send an announcement by Thursday itself.
Yeah, there will be exam.
Okay.
Okay,
No
and
issue. But
ma'am,
please solve the yeah.
okay, ma'am. And ma'am, in total there will be 20 questions, right?
Yes, 20 questions.
Okay, and like what is the time? Like,
Time is I think 1.5 hours.
For
oh,
each
okay.
subject, right?
Yeah, for each subject. For CT, 1.5 hours.
So ma'am, it will take place for in two slots, right? Or together itself for all the four subjects if one has taken four
That I am
subjects.
not entirely sure. You can ask support about that. I'm not sure. But for CT, you'll get 1.5 hours in the interim.
In two slots only. This will be afternoon and forenoon, just like that.
You will get all the information via your email. Okay, so just by before Thursday, I will let you know about the Friday slot and whether your mock is graded or not. For
Okay,
now, if it
ma'am.
is showing this deadline, then consider it graded only. You first attempt it, then on Friday or Saturday, we'll discuss.
Okay, ma'am.
Okay, thank you. Thanks, everyone, and all the best for your exam.
Thank you, ma'am.
Thank you, ma'am. Hello, ma'am. Hello.
Yes.
Ma'am, in quiz practice, there is no computational thinking previous PYQs.
Sorry, come again.
Ma'am, in quiz practice, there is no computational thinking course.
Quiz
Mock test.
There is a mock we have released, so that one I'm asking you to solve.
Okay.
Just solve it by this week. We will discuss it on Friday or Saturday.
Okay.